Hi everyone. Today I'm going to be talking about the relationship between the western extent of the Bermuda High and the pattern in surface ozone concentration in Houston in the summer. So first I'm going to talk a bit about the patterns that surface ozone can have. So what we're investigating here is this pattern that occurs in Houston in the summer where ozone in June is a little bit higher than ozone in July. And then after it's low in July, ozone tends to increase later in the year through August. And this data here is rough, but the same pattern is true of sets of data using larger time spans that actual researchers have used. Now, there's also a diurnal pattern to surface level ozone, which makes sense because ozone requires precursors to be broken down by the application of solar radiation. So diurnal ozone concentrations tend to have a minimum right before dawn. And then once the sun comes up, ozone production increases a lot and ozone reaches its maximum concentration in the afternoon. And then once night falls, since ozone is unstable and there's no solar radiation to continue some of those reactions, ozone concentration decreases. I'm also showing you this because one of the pieces of research that I was looking at uses diurnal patterns to cluster together different days of ozone data. So we'll be looking at that momentarily. We've already discussed the Bermuda High in class. Just to remind you, the high pressure area is caused by the substance of air that had risen at the equator due to the higher temperature there. And then the interaction of the pressure gradient causing air to start moving with the Coriolis force causing the rightward twist of air in the northern hemisphere, leftward in the southern hemisphere, results in a circulation pattern that goes clockwise around an area in the middle of the North Atlantic. And also at the bottom of this, friction with the surface causes the transport of air or the airflow from high to low pressure. So there's divergence of air around the Bermuda High as well. Now, looking at some data about pressure and the Bermuda High, we see that the pressure is higher in the center of the Bermuda High in July on average, and the areas of the same pressure go farther to the west, hitting close to Houston in longitude in July, whereas in June and August, the western extent of the Bermuda High is not as far. And one way to measure the extent of the Bermuda High is just that, to use longitude and find the longitude at which a piece of air, an air parcel 1,560 meters above sea level would have a pressure of 850 hectopascals exerted on it. And you know how I mentioned that those researchers were using diurnal patterns to cluster data? So this is one of those clusters. So each of these comes from data with a similar diurnal pattern to it. And you can see that in 2011, which was a drought year with unusually high ozone in the summer, the western extent of the BH is very, very low. Whereas in 2014, which was a much cleaner year ozone-wise, the western extent is much farther. However, there is a sort of sweet spot to this because if the western extent of the BH is so far that the high itself, the center of the high with substance, is over land, then that land is going to experience more stagnant airflow and also dry conditions that encourage ozone production. Whereas what's happening here is that the currents around the BH are going through the Gulf of Mexico and picking up warm, clean air. And then when they bring it over Houston, the moisture blocks solar radiation for one, which is needed for ozone production. So that decreases ozone production. And secondly, the fact that the air coming in is clean, it disperses pollutants that can act as precursors for ozone. Now, another pattern which is similar to the Bermuda High and tends to be reinforced by the Bermuda High is the low-level jet, which is caused by a pressure gradient between the Gulf of Mexico and the Great Plains. And so it's a southerly wind that flows very similarly to, in a direction very similar to the Bermuda High. And so generally it does the same thing, picking up warm air from the Gulf and washing over Houston with it. But in 2011, which I had mentioned was a drought year, it's possible that something different happened. So you're definitely familiar with this diagram. And it could be that during that year, the inflow from the Gulf to Houston was not as great as the outflow from Houston to the Great Plains due to a difference in the way the gradient was set up. And so if the gradient was less from the Gulf to Houston, then there wouldn't be as much warm, clean air transported into Houston. And any moisture that wasn't Houston would have been transported out to the Great Plains and causing drought conditions where, again, this dry air without any moisture in it, and also the stagnant nature of the air would result in higher ozone production. So I thought that was pretty interesting. I hope you did too, and please let me know if you have any questions. Thank you.